Hey guys, so today we're going to look at ellipses, which is our first conic section that we're going to look at. Okay, and you might look at a picture of an ellipse here and say, oh, it's an oval. Okay, but there is more to it than that. Okay, so the definition of an ellipse is the set of points for which the sum of their distances from two fixed points, called the foci or focal points, is constant. Okay, so right now, let's ignore that, what exactly that means. I don't expect that to make sense yet, but we're going to dive right into what these look like, and then we're going to revisit that definition at the end, and hopefully it should make more sense to you. Okay, so the very first thing here, we have two equations side by side that look almost identical, and you should notice there's just one difference, which is that a squared and b squared are switched. Okay, on the left, a squared is first, then b squared. On the right, it's switched. We'll go into what that means and what the difference is in a minute. Okay, the first thing I want to go over though, what do these different letters mean? Okay, so you have h, a k, an a squared, and a b squared. And guys, this is called standard form. So both of these are in standard form of an ellipse. Okay, and that should be a familiar term for you. Standard form is something that you've dealt with in plenty of math topics in the past. Okay, so first, the center point of your ellipse is h, comma, k. Okay, so those letters H and K are helping you determine the center of your ellipse. And that might sound familiar from another shape that you've done in the past, which is a circle, which also uses H and K for the center. Okay, so you see I've written here for each of these two examples, the center point. Okay, so it's x minus h. So in the equation, x minus 1 means h is 1. Y minus k. So 2 would be k, so your center is at 1, 2 in the equation on the left. On the right, x minus 3, so 3 is your h. And then you just have a y squared, so that's really like y minus 0. Okay, so your center would be 3, comma 0. Okay, so now going down to your graphs, you're going to plot those. Your center point is where you start when you're graphing. Okay, and you'll notice I'm color coding things here to try and keep it organized so you guys can make connections between, where I'm getting these things from the equation and then what that translates to on the graph. So in orange, you'll see that's the center, 1, 2, and 3, 0. Okay, so the very next thing would be what's the difference between A and B? Or in our equations, you see they're A squared and B squared. Okay, A is always the bigger one. Okay, so you'll see I've written here A is greater than B, and I'm going to color code it A in red, B in blue. Okay, so you determine which one is A and which one is B by looking at the denominators and asking yourself which one is larger. The larger denominator would be A squared, the smaller one, B squared. Okay, so on the left, the two denominators are 9 and 4. So your larger one obviously is 9. So that's what we're going to call A squared. So if A squared is 9, and I want to know, well, what is just regular A? I have to take the square root of 9 and I get 3. On the right, A squared, the larger one, is clearly 16. So I need to take the square root, and so A equals 4. And we're going to need to know what A is and what B is, and you'll see why in a minute. Okay, so now B. B squared is the smaller denominator. So on the left, B squared would be 4. And to get just plain B, when I know B squared, I got to take a square root, so that would be 2. On the right, the smaller denominator, B squared equals 1. The square root of 1 is also 1. Okay, guys, so the next question is, what am I doing with A and B? Okay, they're going to help you create endpoints on your ellipse. And so what you need to now notice is my A squared under X or is it under Y? So you'll see here on the left, A squared is the denominator under my X term, not Y. Okay, and so if you guys remember, think about graphing. X values go right and left, and Y values go up and down. So since a squared is under x, I'm going to go a units right and a units left from the center. Okay, so looking at my graph down here on the left, since a was under x, from my center point, I go a units to the right and a units to the left. Okay, a was 3. Okay, so from that center point, I went 3 units right, 3 units left. Okay, and I have 2 endpoints here now that you can clearly see. Okay, and we'll do the same thing on the right. A is 4, but what's different about the right equation is that a squared, the larger value, was under y here, not under x. Okay, so we remember from graphing that y values go up and down. So since a happens to be under y here, whatever a is, I'm going that many units up and down from my center point. Okay, so looking at my graph on the right now, from my center point, I go up by a and down by a. Remember that a was 4. Okay, so from that center point, I went up 4 and down 4. All right, so next we're doing the same thing with b, except on the left, b squared is under y. So I'm going up and down by b. B was 2, so from my center I went up 2 and down 2. And on the right, B was 1, but B squared was under X. X values go right and left, so from the center I went right 1 and left 1. Once you have drawn those 4 endpoints, that's all you need to make your graph, to actually draw your ellipse. That's all I'm requiring you to do. So I'm going to connect all 4 points. Remember what the generic shape of an ellipse is. You know, these shouldn't be straight lines connecting them. It shouldn't be a diamond. It is more of that oval shape. Once you connect those 4 points, you have drawn your ellipse. That black line that I've just drawn is the actual ellipse. All right, guys, so now a little bit of vocab. If you remember from learning circles in the past, they have what is called a radius from the center to any point on the outside. Okay, there are not radii when it comes to ellipses, but we're going to have, each one is going to have 2 axes called a major axis and a minor axis. Okay, they both go through the center of the ellipse, and like you might guess, the major axis is the longer one, the minor axis is the shorter one. So I'm going to draw them in now, and it might help you to go to shapes on the left and use your line tool. Okay, I'm going to stick with red for the major axis, so I'm going to connect these 2 red endpoints right through the center of the ellipse. Okay, and then on the right, on the right, I'm going to do the same thing. Okay, connecting my 2 red endpoints. And you guys see that on the left, the major axis is horizontal. On the right, the major axis is vertical. That's because the equation on the left had a larger denominator under a, or under x, excuse me, and on the right, we had a larger denominator under y. Okay, so now the minor axis would go the other way. So again, I'm going to use my shapes, my drawing tool, and I'm going to go in blue. And my minor axis goes through the center and connects those 2 blue dots. So on the left, the minor axis is vertical. On the right, the minor axis is horizontal. Okay, so the endpoints of the major axis are called vertices. Okay, so here are my 2 vertices on the left. On the right, here are my 2 vertices. Okay, and then the endpoints of your minor axis are called co-vertices. Okay, so in blue, here are my co-vertices. Okay, so those are important definitions or vocab words that you need to know for this unit. And a common question you might get would be like, what are the coordinates of the 2 vertices? Or what are the coordinates of the 2 co-vertices? Okay, and so basically those 4 points, your 2 vertices and 2 co-vertices, are what you connect to make your actual ellipse. All right, guys, so the last component to this graph, and you might remember seeing this word in the definition of an ellipse, is the word foci or focal points. Foci is the plural. Okay, so your foci are C units from the center point, and they're always on the major axis. Okay, so what is C? You're going to use this equation here, C squared equals A squared minus B squared, to solve for C. And whatever you get, you go that many units from the center point, either to the right and the left, if it's a horizontal major axis, or up and down if it's vertical. Okay, guys, so first here on the left, see my equation to help me find the foci, C squared equals A squared minus B squared. Okay, so A squared and B squared come from your denominators. Okay, so you got to go back to your equation. A squared and B squared were 9 and 4. So C squared is 9 minus 4. That means C squared equals 5. Be really careful. A lot of students will then say C equals 5. Don't forget, that equation is C squared. I need just C. So in order to get C from C squared, I take the square root. And so C is radical 5. You want to put that in your calculator to get an approximate value. It's about 2.2. Okay, so now my foci are 2.2 units from the center, but I have to go along the major axis. So here the major axis is my red one. So to the right, 2.2. And you can guesstimate what 0.2 looks like. And to the left, 2.2. Okay, and those are my foci. They are not actually on the ellipse. They're always on the inside. Okay, so now on the right, C squared equals A squared minus B squared. Well, A squared and B squared are 16 and 1. So C squared is 15. I need just C, so that's radical 15. Put it in your calculator. It's about 3.9. But what's different about this one on the right is I go up and down. My major axis is vertical here. The longer axis is always where your foci lie. So up by 3.9 and down by 3.9. And there are my focal points for both of these ellipses. All right, so we're almost done. One thing I should have pointed out sooner. Okay, on the left here, you would call this a horizontal ellipse, and on the right, a vertical ellipse. And it's pretty intuitive why they're called that. Horizontal ellipses are longer right and left than they are up and down. Vertical ellipses are taller. They're longer up and down than they are side to side. Okay, you could say a horizontal ellipse, the major axis is horizontal, goes left to right. And you can always tell that from the equation because based on which denominator is larger. Okay, so on the left, larger denominator 9 is under x. On the right, the larger denominator is under y. When the larger denominator is under x, you're going to have a horizontal ellipse. When it's under y, you're going to have a vertical ellipse. Okay, so now we're done graphing and figuring out all this important information about these equations. I want to revisit the definition. So the definition of an ellipse, we said it's the set of points for which the sum of their distances from two fixed points is constant. Okay, so what this means, your two fixed points are your foci, the sum of distances. If I take any point on my ellipse, let's say this random point right here, and I add up the distance from that point to one foci plus the distance to the other foci, whatever I get for that sum, let's say the sum of them equals 10. If I take some other random point on my ellipse and I add the sum of this distance to foci number 1 plus this distance to foci 2, that's going to also equal 10. Okay, so the idea is not that they're equidistant from the center point, but the two foci are your key points where you have to add the sums from any particular point, the sums of distances to one focus plus the distance to the other one will always equal that same sum if you do the same thing for any other point. Okay, so wrapping up here, If you hit select on Cami, you can click these links. I've added a real life applications page, which you can take a look at. Football, that might interest some of you, but I find the most interesting real world application of ellipses, because I know you're all going to ask, why do I need to learn this? When have I ever used this in real life? Well, planets, planetary motion. You guys know the Earth orbits around the sun, and you might think that that orbit is a circular motion, but actually it is an ellipse. Okay, so the planets orbit the sun in an elliptical motion. So basically, the sun is one of the two foci. All right, so that's pretty cool if you guys are into astronomy or planetary motion. The planets orbit the sun in an elliptical motion. All right, and last thing, guys, returning here, the second video I've shared for you, you should please watch the entire thing. Okay, this video is an activity that normally we would do in class together, but given the unique circumstances, it's a little bit difficult. Okay, but this is an easy, cool way to construct an ellipse on your own. 2 toothpicks and a rubber band. And if you pull that rubber band tight and then basically go around your 2 toothpicks, you'll see it forms a perfect ellipse. Okay, so my question to you guys would be, what's the significance of the 2 toothpicks? Okay, basically, what do they represent here? All right, guys, so that's it. Make sure you copy down these notes. Tomorrow in class, we will spend time practicing with these and basically graphing ellipses given their equation. All right, have a great day, guys.